My name is Rashesh. Today I'll talk about cool controller and how we support Kubernetes for Collabora Online. Yeah. So what is cool controller? Yeah. It is a specialized solution for deploying Collabora Online effectively within the Kubernetes cluster. Some of the core problems with cool controller Collabora Online when you have multi-cluster, multi-server configuration is that you need to make sure that when you have a two differentiation from for the same document from two different browser, we need to make sure that in this example, if browser 1 and browser 2 opens the document B, we need to make sure that it goes to the same Collabora Online server. Otherwise, you would have horrible problems. You would have data overwrite because the both session will be open in different Collabora Online and they don't know about each other, what's going on between them. Yeah. And the other problem is scaling performance. For some, not for some reason, Kubernetes is is slow when you start to auto scale. So in general, Kubernetes, depending on your service provider, it can take 1 to 2 minutes or maybe 5 minutes, depending on the service provider to create new nodes, new machines to accommodate the load. These are some of the problems that we try to address using cool controller. Beside this WebSocket connection, which needs to go to the same Collabora Online pod, there are different requests that also depends on this session consistency, like clipboard and media requests. For the way to compensate the waiting time of this service provider, what we do is once the new ports comes up, like after 3 or 5 minutes, we get to know that in the cool control, and cool control will try to move some load around and to make sure that documents are divided between the ports, so it doesn't degrade the performance for the users. This is what it looks like when you deploy cool control and Collabora Online in the Kubernetes. So this was like a refresher of the talk that I did last year. But now let's move on to the updates, the recent updates that we have done for it. One of the key thing is we wanted to test the big clusters, right? Because that's the point of Kubernetes. Yeah. So for that, I need to scale Collabora Online to hundreds. If I want to scale the Collabora Online to hundreds of pods, it would be very hard for my local machine. Of course, I don't have those type of resources. So what I tried is I created the mockcool. I call it mockcool. So it mimics the cool functionality, like what controller depends on. So controller sucks out a lot of data from Collabora Online. So the controller depends on this interaction with the Collabora Online. So yeah, if I wanted to test it hundreds of pods, I need to have something very less resource intensive. for testing it locally. So I created a mock cool application to go with to test the large clusters, and it helps me to make sure that cool controller behaves consistently with the large clusters as well. And yeah, and the other thing that we did last year was umbrella Helm chart. I don't know if you know. I mean, if you are from Kubernetes background, but Helm charts are like bunch of YAML file. You throw them together, and they create Kubernetes objects to make life easier for sysadmins. So before creating an umbrella Helm chart, we had two different Helm charts. One was for cool, and the second one was for controller. So what you had to do is like configure your cool controller and configure cool separately, then install them both separately. It creates a friction for the sysadmins. So we created a parent Helm chart. Now both the Helm chart combines together, and you create just one file, and you can just deploy that Helm chart, and you can have your setup ready. Yeah, and the other recent thing I did was geolocation. Yeah, so if you have asked for demo accounts from Collabra website, you generally get 4 links for different regions. One for US, one for EU, and one for Japan, and one is for South America. Depending on what you want, you click on it and it creates a demo account for you, etc., etc. But it makes our life harder, and users as also. So we need to maintain 4 different instances for OP host instances. For demo, we have Nextcloud own cloud, and we have to for 4 different regions, we have to maintain 8 different OP host instances. Yeah. So the problem is that Cool relies on WebSocket connection, and if you want to make sure the Collabra is performing at its best, is to connect to the closest server. Yeah. So the goal is to have a centralized OPOS instances and different geographically different cool instances, and so that when user opens a document in your central OPOS instance, they connect to the closest Collabra online server. It's few of the challenges that I had to face while doing that is we design cool controller for Kubernetes deployment, and our demo servers are using traditional VMs. So I needed to port the cool controller to work on the VMs, and that's it. Yeah. And this is how it works. We will open a document. Client JS would send a request to the cool control, which server it should go to. The request should have time zone. So depending on the time zone, cool control will give the address. The domain of the server which is closest to the user. This is what architecture looks like. So there are 4 different VMs, and cool controller is running in demo view, and the communication happens like I previously mentioned. Goal control has information about what's going on within the servers. So it can decide which goal server the request should go to. I have same slide twice. And yeah, so it makes sure that you always connect to the closest servers. Yeah, that's it. That's it for me. Thank you. If you have any question.